All right. Hi, everyone. I'm Deidre. I am the workshop designer here at Live in Farms. I'm just going to introduce you really quickly to my coworker, Christina, who will be taking the questions for today. So if you do have any questions, please write them into the chat, and she's just going to make sure that I get around to them. All right. So let's see. Today is the third webinar for your Waste to Edible Greens web series. And today we're going to be talking about insect growing technologies. And later, after the presentation, I'm actually just going to walk you through cleaning the Hive Explorer and what that is like in just different processes. And I can answer some questions during that time. Okay, so you might be wondering at this point what insect growing technologies are. We have these insects that really do some pretty amazing things in the natural environment. And I'll explain a little more on the specifics of what an IGT actually is, but just know that insects have these superpowers, and if we are able to have them do these things at a larger scale, it could really help with some pretty pressing sustainability issues. Okay, so let's just first start with insects. And I know people tend to have quite an adverse reaction to insects normally, and that's perfectly fine. I love working with insects, but even for me, there's like specific types of insects that kind of creep me out, honestly. And so just know it's normal. Insects are polarizing, but regardless of what we think about them, they do some very important jobs in the environment. And part of what makes them so amazing is just the diversity of their abilities and things that they can do. And what I have on this slide are basically just examples of different insects and different jobs that they perform. So the first is a ladybug, which is a very voracious predator, as I'm sure a lot of you know. And their favorite food are aphids, which happen to be pests, especially in people's gardens. And so ladybugs will come in and they are hunting these aphids, and in doing so, we benefit because our flowers are healthy, they're not being eaten by aphids, and the ladybug gets to be happy. It's well fed. And the second is a bee. There are many different types of bees, and bees are obviously, a lot of them are pollinators. They're pretty much pollinators. And as mentioned in the last few webinars, bees play a very important role in our food systems and making sure that the plants are pollinated so that you can get diversity within the plants and that they bear fruit. And so we really benefit from having them around, and we don't fully understand the entire scope of the types of plants that bees actually pollinate. So we need them more than we actually understand. The next are dung beetles, which we have on the lower left. And yes, they deal with poop, which is kind of disgusting, and a lot of dead and decaying matter. But in doing so and in dealing with all of that stuff, it actually prevents us having to deal with it, or rather other larger organisms, because they do help with the processing of these wastes. And without them, we would have a lot of waste piling up everywhere, and it would be pretty disgusting, and there would be a lot of disease going around. And lastly, we have on the bottom right is the silkworm, and this is in a setup in Thailand. This is a traditional technique for harvesting silkworms. Sorry, I said mealworms. Silkworms, because this little corral, I guess, for a lack of a better English word, is where these silkworms will eventually become pupae and make themselves their own silk cocoon. And if you want to learn a little bit more about that process, I do mention it in one of the previous blog posts, so you can just check that out on the Live in Farms website. Okay, so they perform these really important jobs, and insects perform very important jobs. And Actually, the next insect I'm going to show you is something called a hoverfly. And this insect is very special to me because it helped introduce me to the world of insects and to how amazing and diverse these animals are. The hoverfly, which is, by the way, this larger fly, not the smaller one, as you can see, looks a lot like a bee, or at least if you squint your eyes, you can see there's a yellow and black coloring, which is very reminiscent of bees and wasps. And while these hoverflies have no stingers whatsoever, of course, when you see an insect with that coloring, automatically you just think that it would have a stinger, which is on purpose. That coloring will immediately tell predators that likely there's a bee or a wasp around, and so they'll largely leave these hoverflies alone. And because of that adaptation, hoverflies are able to go around and live their lives without having to worry too much about predators eating them. It reduces the chance that they'll be eaten because of this coloring, and in doing so, they can survive and have offspring. And hoverflies, even though they are flies, we tend to think of flies as dealing with a lot of waste and decaying matter, but these flies are actually pollinators. They're not known to deal with any kind of organic waste. And so in a sense, they are a little like the bees, and they do help different kinds of flowers pollinate and bear fruit. And so that's a role that they fill, and that's one species that I've worked with. And just imagine that we have all these insects performing such amazing tasks. I will actually go back to here and talk about the bee a little bit, because there have been in recent years attempts to make these small drones to help pollinate different flowers. And while it is, of course, like a great idea, considering, or not a great idea, but like it's a very interesting idea because there are global declines in bee population. The biggest hurdle that they're coming up with is just these drones are not nearly as agile as these bees, which makes actually a lot of sense because bees have been around for millions of years. They're very good at what they do, and they're able to do it very well. We've only been around for several thousand, so it's anything that we could come up with is going to pale in comparison to what they do. And so let's think about these jobs, knowing that there are these particular jobs that insects do that they're so good at doing. Insect growing technologies take one particular species, a species that we would consider useful or helpful to us in the job that they do, and the IGT just gives them a place to live and grow so that you can have a larger number of them. And by increasing the number of this specific species, you thereby amplify the jobs that they're able to do. So you can make them do a job at a larger scale, because like a single insect is quite small, right? And so on the slides, you can see that there's these three examples. The first two all three of these are examples of past devices made by the company founder, Katarina Munger, and the first two deal with black soldier flies, which are a type of fly that food waste and decaying matter. And these IGTs, you can see they have these domes because flies need to fly around, and then there are these holes where they can mate and lay their eggs, and the larvae can grow. And in the last one, that's a prototype of our current device, which runs on yellow mealworms. And you can see that there's different levels so that you can grow a lot of different mealworms at the same time, and thereby give it more food waste than just if you had like one tray, for example. Okay, so the insect growing technologies, if we think about the concept that we learned from the last webinar, which was about systems, we'll see that there's an input, process, and an output. And the process actually relies not on anything that we have to do really, but on that particular insect species that is of interest to us. and they're just doing that one job. A lot of times that can be like digesting things, for example, or it can be creating. It's something that they create, which is important, like silk, for example. So we take an input, which is low value, something like food waste that we don't really personally use and we don't have use for, and putting it into the technology, the insects will process it, and out they will produce an output that is high value, something that we do find useful, such as fertilizer or soap. And so what the IGT is doing is just keeping these insects happy. They're giving them a place to live. They're making sure that they have the right temperature and humidity, and we give them food and all of that. And so here's just a slide talking about our current device, the Hive Explorer 2.0, and the different sensors that it has, and the fan and the heating tray, all of these to say that these are like the different technologies that are used to keep the mealworms happy, and that's all plays a part of this insect growing technology. Okay, what I'm going to play for you really quickly is a video, and this is just an example of a larger scale insect growing technology from Indonesia. So why don't we watch that? Okay, I'm just going to play this really quick. Okay, and just know I'm going to put the sound on, but if the sound quality is not that great, feel free to mute it. I will put the subtitles on so you can see that.
Let's start with the BSF rearing unit, the heart of the facility. This is where we produce millions of small larvae every day. Life usually starts with sex. In our case, mating takes place in the so-called love cage. We provide the flies with a water source for drinking, space for mating, and a place where the females lay their eggs, the so-called eggs. After a week of hard reproduction work, most of the flies have died and we remove the larvae. We bring the harvested eggs to the nursery where they are placed over a tray. When the young larvae hatch, they fall into the feed where they immediately start to feed. Due to the constant rain of hatchlings, we call this hatchling shower. After 5 days of feeding, the young larvae, so-called nematode, are ready for the waste treatment. We need about 600 to 800,000 larvae for 1 ton of waste. We just have to separate the larvae from the feed and count. Of course, we only count a few grams and extrapolate the total number. The portioned young larvae are then ready and fused with the waste. A small fraction, let's say about 1% of our young larvae, will be needed to keep the colony running. They are fed a mixture of chicken feed and water for about 2.5 weeks, until they transform pre-pupae and are ready to feed. They do this in boxes with a moist pupation material where they will bury themselves in metamorphosis. The time it takes from pupa to adult varies from 10 to 20 days. We place the pupation boxes in so-called dark cages. Now, whenever a fly emerges, it will remain calm and wait, because activity in general and mating of the black soldier fly in particular is stimulated by light. When we want to set up the new love cage, we connect the 2 cages and lure the flies into the love cage with a lamp. The cycle is completed and the whole game ends. Now that we have seen how to produce young larvae in great and defined numbers, we move on to the actual bio-waste treatment. In the case of our facility in Indonesia, we receive waste from a fruit and vegetable market. To make the waste easily accessible for the BSF larvae, we shred it with a hammer mill, but any kind of shredder can do that. Our fruit and vegetable waste mix is very wet. Therefore, let it drain for a day or 2 to reduce the water. Here you can see the treatment setup. We work in crates because one person can handle them and we can stack them onto a pallet. In every layer of trays, there is a metal frame which allows air circulation. The larvae stay in the trays for 2 weeks. During this period, they are fed 3 times. That means that every pallet treats about 500 kilograms of weight. Once the larvae have reached a good size, the whole pallet can be harvested. Because we have very wet substrate, we put the residue and the larvae on the screen, where the liquid flows and the larvae crawl through. The larvae can then be strained from the liquid. The larvae are rinsed with water before being further processed. But what to do with the larvae now? This really depends on the local situation. If your customer is nearby, you might be able to directly feed the larvae to the fish or chicken. If you want the product that is easier to store and transport, you have to think of methods to kill and dry the larvae. We are currently testing a pelletizing machine to produce easily marketable fish or chicken.
All right, so I hope you enjoyed that video, and if you didn't, you're welcome to watch it again. Okay, so let's talk a little bit about this rearing unit, this rearing facility. This is a facility just outside the city of Surabaya in Indonesia, and takes the waste, the organic waste coming from the city, like in this case, which was the food market, and processes it into fish and chicken feed. And if we look at this in terms of systems, again, we see that the insect, the processing insect, is this black soldier fly. And the input they take is this organic and food waste, which is, again, of low value, at least in the state that it is. And they take that from the city and they bring it over, they feed it to the black soldier flies, and what you get out of it is more black soldier fly larvae that get to grow and eat the food. And that is able to be given and sold as fish and chicken feed, especially to people in the surrounding communities. Okay, and if we look at this as how it relates to the Hive Explorer, you see that it really is quite similar to the diagram I just showed you, except instead of using the black soldier fly, we are using mealworms. And realize that this, while the last one was an example of a large-scale insect growing technology, that was an entire facility that took up several buildings. The Hive Explorer is an example of a small-scale insect growing technology. And it's just a desktop version. It fulfills very different uses. While that one is used to process waste coming in from the city, the Hive Explorer is really just for personal and educational uses. So it doesn't make sense to have something so big. And again, we're going to have this low value input, which is the food waste, and we're going to have the output, which is the mealworms and the frass. The mealworms being good because they can be used to be eaten by us. They can be used to be eaten by our pets, like hamsters, for example, really love them. You can give them to your cats and dogs, because if we remember that animal protein is a big contributor to greenhouse gases and thereby climate change, we often don't think about how pet food plays into that, because cats and dogs are predatory animals, so they need quite high levels of protein in their diet. And I'm not saying you give them only insects to eat, but at least just mixing some of them in will decrease your reliance on animal feed in order to feed them. Feed your dogs, your pets, I mean. And then the frass can be kept. That's a waste product traditionally, but of course we can keep it, and by diluting it, we can actually use it to help with our plants. Okay, so at this part of the lesson, generally we have students design their own insect growing technologies. We give them 2 different insect species. We give them either the mealworm, the yellow mealworm, or the black soldier fly. They can choose. And from the additional information we give them, they design their own IGT. They design it, they actually build it later with recycled cardboard, and at the end of the lesson, they will present it to their classmates. Okay, but obviously we're not going to do that today. I'm actually going to take the time to show you the process of cleaning out and maintaining a hive. This is just regular maintenance, not the full-blown maintenance. So I'm just going to stop screen sharing for a second. And I'm going to turn the background off. Okay. Awesome. Okay, so again, what you have here is the Hive Explorer 2.0. I generally have a dish with me when I do this. Tissue is always good. And I like to have tweezers or a small spoon. So I just want to reiterate that we do have this filter right here, and when you open, you want to start with this flap side. It's generally the easiest part to open. You just kind of push this tab up, it will open by itself. But for the rest of the sides, you just want to be a little more gentle, and you're going to use your thumb to just push up along the entire edge. And you're going to go around and do the same on the other side. And it's quite snug because it is supposed to keep natural odor from coming out. And honestly, when the cap is on properly, I never notice it in my own home. And then the other reason is because insects have this habit of being able to escape really easily. I've worked with rearing quite a few types of beetles, and it's kind of amazing and how often they get out. They are just masters of escape. So it's even more amazing that this top, actually, I've never had any issues with these guys escaping before, which is very rare in my experience. Okay, so I've put the cap to the side here, and I'm just going to take a look first at the setup. These little brown parts are actually because I fed them some coffee grinds earlier, so they're still in there. And that's totally normal, but I just actually fed them this morning. So I'm going to take this cup, I'm going to take these tweezers, and I'm just going to go around and I'm just going to check to see if there's anything that isn't really moving. Then I'm just going to pick it up. There's a lot of different, for example, this part of the shell of these guys, that tends to come off as well. It's perfectly natural to see dead insects. It happens quite often. They have very varying lifespans, and you want to take them out of the hive because, of course, once an animal or once an insect dies, it's not going to, its body is going to start to decompose, and you don't want that happening in your hive. It's going to create a bad smell. It could introduce diseases, and so this is an important part of cleaning. And a question I'm often asked is, like, what do we do with these bodies? If we're going to go with, yeah, that's a pretty morbid way of thinking about it, but what are we going to do once we've taken out the dead insects from the hive? Like, is there anything we can do with these other than just throwing them away? And yes, there is. As I mentioned in the second webinar, where we talked about systems, the Hive Explorer is a linear system, which means it's going to create waste. However, we can reduce this waste that's created by making a system, an outer system that helps to recycle the waste that is generated. Okay, that's just a fancy way of saying that you can compost these guys. That's one way to reduce the waste. So instead of throwing away the waste, since this is all organic anyway, it's going to naturally decompose. We can put this in the compost with all of the excess food that can't be fed to these guys. And in doing so, we can use that to grow plants at home. I will show you in a later lesson how to grow microgreens, and microgreens can be used to are things that you can eat, and honestly, they're not the cheapest at the supermarket, so it's pretty great that you can grow them on their own, and they grow really well on the frass of these guys. They really like all those nutrients. Okay. And during this time, I like to just check. Take a check. I look underneath. I'm not going to tilt it, but I look underneath here just to make sure there's no mold growing. I look in this tray to make sure if there's any poop. I'm going to set this aside right here. That I get rid of it. You just want to tap it a little. Sometimes there will be tiny baby mealworms, so in the event of that, I will just shake it a little bit and put it to one side. So then the baby mealworms are in one area, and when I give food, I'll give food over here and here, but I can also put a little bit of feed on that side where the babies are. Okay, and then when I'm done with that, I'm gonna pick up this and move it to the side. I'm just gonna check on the mealworms here. This is a great time to check that while you're cleaning them up, that there are babies being born, hatching, and helping your colony grow. You can see like this one's a baby right here. Babies can be even smaller than that actually. It can be, there's a little tiny one over here. I don't know if you guys can see that small. I'm just saying hi to your mealworms. Hi babies. And just checking on their health, making sure there's no mold growing anywhere. And okay, so there's a pupae right here. And even sometimes the beetles, this doesn't happen super often, but the beetles will sometimes manage to crawl out. Perfectly normal. All you have to do is take the pupae or the beetle and you just pick it up and then put it in the proper layer. Okay, so you can see this guy was just squirming when I moved him. Remember that the beetles and the mealworms will eat, but these guys won't eat. They're actually going through their metamorphosis, and it can be kind of hard to tell sometimes whether they're alive or not. What you can do is just, you have to be very gentle, but when you pick them up, try to pick them up on the head as opposed to the tail, because the tail is quite soft. And then you can always see that they're alive because when you poke them, or if you just hold them very gently, they're already letting you know that they're alive. They're kind of kicking around and just saying, hey. There we go. See? But for the most part, please leave them alone. Okay, and then lastly, I'm just going to check this last layer. And you can see there's some frass here, but it's not a whole lot actually at the moment. And so that's okay. Generally, there'll be like a whole coat. And all you have to do is take this out. You just kind of, you tap the tray and shake it a little bit, and you can keep the frass for later. I generally use an old bottle or glass jar that I'm not using anymore, and that's where I'll keep it so that if I need some liquid fertilizer, I can just take a teaspoon, mix it in with water, and then that can be fed to my plants. Okay. All right. And while I'm picking up more mealworms, I will just cover some questions. Let's see that people are asking. Okay, so I have a question. I've gotten a question that is, what do we do with the mealworm bodies? As I said, you will generally want to compost them. That's how we kind of keep the circular system going. If you don't have a compost, you will ultimately throw them out. But that's why it's important to learn about what it takes to make a system circular. And I will actually walk everyone through how to set up their own bokashi fermentation or bokashi composter, and talk more about the composting process with you all later. I've also been asked a question about what use that the bodies have. I'll stop saying bodies, sorry, the dead mealworms have. And the big thing is with these mealworms and the beetles especially, is that one of the main things about insects is that their outer body is made of this chitin exoskeleton. Chitin is really great because it's very strong. It's one of the reasons why you can pick up these guys and they're pretty much okay with it. You can drop them and try not to do it often, but they'll survive. And the chitin actually has antimicrobial properties as well. And so there's a company in Taipei which will take the chitin, not from insects, they actually take it from crustaceans, but they use it to make socks for people, for diabetics. And it helps increase the blood flow, it keeps any kind of bacterial infection down. It's a pretty amazing innovation. There's a lot of things like that with these guys. Like I mentioned really briefly in one of the other lectures, that mealworms can eat polystyrene. They can eat. They're actually one of the few animals that genuinely break the plastic down into simpler parts, as opposed to just having it go through the system, its digestive system. Okay, and I have another question just about reiterating what we can feed and give these guys. I just want to say that there's two different types of food. As I've mentioned before, we have dry food, which is what we have here, it's just these oats. But these can also be things like breads and different types of grain. And then we have wet food. Today's wet food is actually the coffee grounds from my coffee this morning. But the wet foods will be things like food waste. It could be carrots and potatoes, for example, are very good. We like to give them because they tend to not mold, which is great for these guys. It really also depends on where you live. During this whole process, while I'm checking these, I do also want to check under the trays. I want to check under here. You can see that while there's mesh here, there is like a supporting structure. I can't flip it over to show you, but sometimes mold will go under there. To combat this, there's these plastic pegs in here. And so all you have to do if you clean out all the mealworms, you can like actually press the mesh down and the pins will pop. And so that way you can clean the mesh separately. And this kind of sums up what my cleaning schedule, which is about like twice a week, depending on how free I am. But every 1 to 2 months, I will take out all the living animals from here, group them together, and then just clean this whole device separately. The plastic used in this, the base, this is all dishwasher friendly, so you can clean it that way if you want. I prefer to just clean it by hand. And just remember that you need to watch out for mold. So it's really great that you can actually remove the mesh as well. And again, I only do that once every 1 to 2 months. It's like a nice deep clean for these guys. Because dirt is natural and it's perfectly fine. Okay, so that kind of sums up everything for today. Just remember when you're done with the mealworms, you're going to want to press the sides again. And before and after every cleaning, it's important to wash your hands. It's not just for your own health and safety, but it's also for the mealworms, because we have a tendency to accidentally introduce different parasites and diseases to these guys without even noticing. So wash your hands, keep everyone happy and healthy. All right, and that's it for today. Thank you all for joining me. I appreciate everyone coming, and I appreciate all the questions. And please check out the blog if you want to see several articles more about insects. If you want to learn more about them, we've had the latest ones that I've written have been about metamorphosis and about the different roles that insects play in the environment. And the most recent one that's going to come out, hasn't been posted yet, but will come out, is about the relationship between mealworms and technology. or I'm sorry, not mealworms, insects and technology. All right. Okay, thank you everyone. Have a great day. Bye.